My name is Florian Kaltenberger. I'm an assistant professor at Eurocom, which is a research center and a graduate school in the south of France. But today I'm not only representing Eurocom, I'm also representing the OpenAirInterface Software Alliance, which I'm going to introduce as part of my presentation. So the presentation in general is about OpenAirInterface. Some of you might have heard of it already. It's a software project. It's an open source software project that runs on the Lime SDR amongst others, and it implements the full LT protocol stack. So all the parts of the radio network, UE, eNode B, plus we also have an implementation of the EPC. What I want to talk about in the next, I think, 45 minutes I have is, well, first of all, what is OpenAirInterface and the OpenAir Software Alliance, the supported hardware platforms, and then I want to show you what you can do with OpenAirInterface. So basically, and this is especially tailored to this hackathon, we see two different approaches that we call the black box and the white box approach, and I'll detail a bit what I mean with that. And we're also here, to help you. We want to show you how to help you with whatever you want to do with OpenAirInterface in this hackathon. And at the end, also, I want to show you some other ongoing activities in the OpenAirInterface community related to the hackathon and beyond. All right, so what is OpenAirInterface? So it's, as I said, it's an LTE software stack which runs on general purpose CPUs. So the mostly supported platform today is x86, but the parts of the code also run on ARM, but not the complete system. It works together with common off-the-shelf software-defined radio cards, like the ones you see here. So there's this card on top here, which is called the Express MIMO card, which also uses a Lime chip, the first generation Lime chip, but the card was built by Eurocom. There are other hardware platforms we support from Ethos and from Nuance, and of course the Lime SDR platform. So you take this, you take our software, which is open source, which is available for free, and with that you can basically run a complete LT system. So core network, base station, and user equipment. All right, so the software today supports mostly, so it's a baseline implementation of release 8 and 9, with some features from later releases. Very recently, we have started to integrate quite a lot of features from release 12, 13, like NB-IoT and things like that. And as I said, spans the full protocol stack, so the RAN and the EPC. What we want to achieve with the software is to build a community of developers, academics, and industrial players embracing open source for 5G. So that's actually very much in line with the goals of this hackathon, to build the community and to change the game mobile networks are operated today. So we want to allow, basically we see this as a stepping stone for people that want to get into the game of 3GPP systems. Okay, so we want people to take our software and to build products out of it and to develop it further. So that's one objective, and the other objective is really to change the way 3GPP works today. So 3GPP today is a very closed system. It relies a lot on patents, and they have a very complicated scheme of a very complicated licensing scheme. And we want to bring the open source into the game here. All right, so just a little information here where you can find more information about OpenAirInterface. We have a web page. Our code is hosted on a GitLab server. So there are two different repositories. One for the radio access network, so that includes the eNode B and the UE, and the other one for the core network. We have mailing lists, so mailing lists for the core network and for the radio part, which is called OpenAir 5G. And then we have a users list and a develop list. There's also quite a strong community in China. We have recently started an official collaboration with BUPT, Beijing University of Post and Telecommunication in China. And they maintain their own forum, which can be found here. All right. So what is the OpenAirInterface Alliance? So the alliance was founded by Eurocom in 2014 with exactly the goals that I presented to you before in mind. So promote OpenAirInterface and its open source licensing model. Okay, I'll say a bit more about the licensing model in a minute. And to support the community of developers and users. So it was started 2014, and between 2015 and 17, so today, we managed to attract different strategic members. So the alliance has different levels of members: strategic members, associate members, and individual members. So the strategic members are the ones that have a seat on the board, that have voting rights, that can decide to start projects, and then can decide really on the strategic direction that the software is going. So there was Orange from the very beginning, TCL, a Chinese manufacturer of phones. Aircom, which is a small company, well, it's not that small really, but the France branch was small, but they have in the meantime they had left again. Nokia, so we're very happy to have Nokia on board now. They officially joined last week after 2 years of negotiations. Technicolor and Fujitsu is in the process of joining. So we're very happy to have all these partners. We have many associate members too. We have Cisco and many academic partners. So for academic partners or for non-profit organizations, it's actually free to join as an associate member. For-profit companies have to pay a small fee as an associate member, and if they want to become strategic members, a little bit of a higher fee. Okay, so that's the software alliance today. So as I said, with the goals to promote OpenAirInterface and the vision of its open source licensing model. All right, the licensing model. So this is one of the innovations as well, or contributions from the alliance. So as I told you, the 3GPP is a very closed system and a very sophisticated system of licensing, and they have developed this system over a long term, and it has served them well, and it protected them well. So we decided, in order to change the game in 3GPP, we would need to go towards them and meet them, and propose a solution that they potentially can accept. So what we did is we created this OAI public license, which is based on the Apache open source license, and it includes additional clauses for commercial use. So for non-commercial use, so for research and academic use, actually nothing, it's the Apache license that applies to you. But for commercial use, we've added this FRAND clauses. So FRAND is the licensing term in 3GPP, fair, reasonable, and non-discriminatory use. So we have included this in the license. So this allows people who contribute to OpenAirInterface to keep their patents. So if they have if there's a part of the standard that is covered by a standard essential patent, and that person who owns the patent implements this in our code, he keeps the right to his patent, okay? But at the same time, his code can be made open source, okay? So that's, I have to admit that's a bit of a controversial thing in the general open source community. But this is the way we see, forward to bring open source into this 3GPP community. So this public license applies to the radio network, because that's where most of these standard essential patents are. Whereas we have kept the classical Apache license for the core network. All right, and so one of the goals of the Alliance is to promote this license, and we're also working together closely with ETSI. There are other people who are following us who are not members of the Alliance who are keeping an eye on this license and evaluating it for potential use. All right. So now, coming back a little bit to the technical side, so what can you do with OpenAirInterface? So there are several use cases which I'm trying to depict here. So basically, you can, as I said, you can build your own 3GPP, your own LTE network by using different components for each of the subsystems. So you can use OAI EPC with OAI Inode B and OAI UE, or you can exchange any of these parts with a third-party application or commercial equipment. So it's people have used OpenAirInterface with other core networks. So we have been using core networks from Nokia. I heard before that Chorus has also tried to use their EPC with our successfully tried with our Inode B, and there are yet others. You can also use our core network with a commercial Inode B, and of course you can use also commercial UEs to communicate with our Inode B. So that's what I call the classical 3GPP network. But you can also think of simpler networks. So you can, if your research focus is maybe just on the radio part and you just don't want to bother with all the functionality of the core network, then you can set up a simplified network. Yeah, we have this so-called we call it the no S1 mode. Yeah, so basically we scrap the S1 interface and we provide a direct IP tunnel to the internet. Of course, this is a little bit of a hack, so you don't have all the functionality of the core network. But if you have just a single Inode B and maybe a few users, so you need to set all the IP addresses manually in this mode, but it allows you maybe to get to your goal faster and simpler. And then Cloudrun. Okay, so I put this as a separate use case because this is this is one of the scenarios also of this hackathon, and one of the activities, ongoing activities at Eurocom and hot topic in general. So you can use OpenAirInterface for Cloudrun deployments. I mean, it's software. It runs on a PC, or it can run in a data center. So it's you know, it has been built, or it's designed to be run in the cloud. So we have some solutions for cloud deployments too. Today you can already split the eNode B in a baseband unit and in a remote radio unit with a simple gigabit Ethernet connection in between. Okay, so there's no CPRI needed. You can use a simple Ethernet interface. And we're working on different architecture splits at the moment, such that you can also split at the level of the MAC and the PHY, or even higher between the centralized unit and the distributed unit. But I have a bit of more slides on this later. All right. Last but not least, some other simulation, some other use cases. So you can also use the software in simulation only. So there's this simulation environment called OAI Sim, which allows you to simulate eNode B and multiple UEs in the same PC. You can have synthetic channel models in between, and you can do performance analysis there. You can even connect this with an EPC if you want. And then we have plenty of so-called unitary simulators. This is if you want to do research on the physical layer. That's very useful. For example, the downlink simulator allows you to test your receiver architectures to derive things like bit error rates and stuff like that. There are also other use cases, but I won't elaborate on them. All right, here on this slide, I tried to compare a little bit the different platforms. So I won't go into details. I'll just mention that the Lime SDR is really the cheapest option out of all of those. So it's the best. How should I say? I think it's the best value for money actually, and it's also it's also good because all of the components are open source. All right, I can make the slides available afterwards if you like. All right, so since this is a hackathon, I thought some of you might be interested to see how to install this thing. So I have to admit we have not yet packaged our software as a snap, but that's in the pipeline. Okay, so that's going to come. So in the meantime, if you want to install this, it's simple. Or it's not too complicated. You need but you need to do some things, okay? Because it's a real-time system, so it's sensitive to the scheduling that you use. It's on the operating system, and it's sensitive to power-saving modes and sleep states and all of that. So you need to disable all of that. So if you want to run that on your PC, you need to make sure that you set your PC to the highest performance, and you need to disable all the sleep states, because that could kill your real-time performance. It works with Ubuntu 16.4.2 or 17. People have made it work with 17 as well. But we suggest 16.4.2 because that's the long-term support version. This version of Ubuntu has kernel 4.8, so this is works both for the core network and the radio network. Ubuntu also ships a low latency latency kernel, so that you can install optionally. This is on top of the disabling all the power saving modes. This is recommended. This changes the behavior of the operating system a bit for real time. If you need to apply a few patches to the kernel if you want support of dedicated bearers in the core network. I'm not going to the details here. There's a wiki where everything is explained, and the snap development is in progress. Typically, so in the past we were always running the eNodeB and the EPC on different machines, but that's no longer the case. You can now run like Quartos does here and the others. You can run the EPC in the same machine as the eNodeB, making a compact system. But you need to take a little care in the installation here. So there's a nice blog post that explains all of this. All right, then you get the code from our server, from our GitLab server. So you can use. We have several branches there. We have the master branch, which is the most stable, development branch for the latest features, which is recommended because we prioritize this one for bug fixes. And then we have feature branches for cutting edge development. All right, I'll go through this quickly, I think. So to install, there's a build script that takes care of almost everything, which is located in the folder CMake targets. So the only thing you really need is the first three options. -I installs all the dependencies. -W LMS SDR compiles it for the Lime SDR, and --eNodeB compiles the LT soft modem, so the main executable for the eNodeB. There are other options here too. You can -UE compiles the UE specific parts, and then there are some debug tools that you can also compile in. For EPC and HSS, the top level build scripts are located in OpenAirInterface scripts. You have 3 build scripts: build SP gateway, build MME, build HSS. Again, with -I installs additional software packages. For HSS and SIM card configuration. So if you want to use the OpenAir core network, you need, of course, SIM cards. There are many sources where you can get your SIM cards from. There's Sysmocom. There's a new company called OpenCells, which I mentioned here, where you can get the SIM cards from. Or you can buy blank SIM cards and a reader and try to program them yourself. You also need to add, configure your HSS, and this is done through a PHP MyAdmin interface. All right, let me skip over that. Those are details. All right, and then you're set to go. So you can run. You have to run the 3 components of the EPC, run the soft modem, the eNodeB, and then either you use a commercial eNodeB if you have the SIM cards, or you can use the OAI UE, which uses a soft SIM to establish the connection. That part. So the rest of the time, the last 15 minutes, I want to spend on talking about, in particular, the relationship of OpenAirInterface and the BT Hackathon. So there was this nice, So I see basically two ways OpenAirInterface can be used in this hackathon. So I call this white box and black box. So black box approach is really you use the OpenAirInterface as a building block in an integrated system. Okay. So you, for example, you decide to use the E node B only. Okay. You decide to use it with the Quartus EPC, for example, and you know you build something around it, something related to the challenges described by the BT Hackathon document. So there's maybe a minimal amount of hacking involved. You know, if you have a special use case, you might need to do some debugging, or you know, but to minimal extent. And then there's the other use case. So OpenAirInterface is the only open source solution. So out of all of the solutions and partners here in this hackathon, it's the only open source solution for the three components. So which gives you a lot of possibilities. So if you want to include new features, either 3GPP features, standard features, or non-standard features, you could even do that. So you can use OpenAirInterface as a baseline, as a starting point to implement all these features. Okay, so it gives you many more opportunities than maybe some of the other components. And in this, and I'm mentioning this because this is also in the interest of, in our interest. Okay, so because since this is an open source project, we're constantly looking for people to join our community and to contribute to our code. Okay, so if you're willing to implement new features, and if this if these features are aligned, or even just roughly aligned with our roadmap, we're happy to support you. We can provide help, and we will see through that if your development is good and successful, that it will be injected back into OpenAirInterface. I mean, that's the basic way open source works, and it's for the benefit of everyone. Anyway, but we're also happy if you just use OAI as a black box, of course. All right, so now I went a little bit through the document of the BT Hackathon, and so I saw a few areas where immediately I thought that's a good use case for OpenAirInterface. So there was this challenge number 2 or scenario number 2, I don't remember, remote connectivity. So and in particular it mentioned 10 megahertz TDD. So that's apparently a band which is attractive for this use case. So today OpenAirInterface runs 10 megahertz TDD without any problems. We don't support all the different TDD configurations, but we support the most common ones. I would be happy to see OpenAirInterface running in such a scenario. I mean, this would maybe it would not. Actually, I have to talk to you guys if it would work on the current Lime SDR in TDD mode, or if you would need to do that in the bigger version with the power amplifiers and the switches. Then another subpoint there was the tethered drone. That's a very interesting subject and very hot as well. So to have a drone that could provide on-demand connectivity for certain remote hotspots or remote spots or hotspots. So maybe if there's an event somewhere, you could fly up a drone that provides coverage for certain numbers of users. So that's actually also a project we have at Eurocom. It's called the Perfume project. So we're actually working on that. We have already a small solution, unfortunately with the competitor here, with the USRP. But that's that's something where OpenAirInterface is used already. So that's feasible. All right, scenario 3, IoT hub. So as I mentioned in the beginning, there is ongoing development in OpenAirInterface for NB-IoT. So NB-IoT was a feature introduced in release 13 of LTE that provides narrowband, the narrowband cells for IoT usage, so that allows to build much smaller devices and less power-hungry devices. So this development is actually well underway. This week we're going to finish the eNodeB transmit path. We should be getting devices for testing in summer, in August. And we're expecting a delivery of at least of the eNodeB part in autumn. So yeah, I'd love to see OpenAirInterface being used for that too. Then scenario 4 was network as a service. So and here Cloudrun is definitely an interesting application. So I have a few slides on that afterwards. So I'll talk about it later. And then, yeah, other use cases that I can imagine is so we talked about this in the break before. There's decked guard bands, which is apparently a very hot topic in the UK. So there's spectrum there, I think 3 or 4 megahertz of spectrum to be used. That would be good if we could use OpenAirInterface for that, but that would require some changes. So for LTE to be used in a guard band, you would need to use a configuration of 15 resource blocks, which is currently not supported by OpenAirInterface. So this would need to be added. Other scenarios I can think of, so massive MIMO. This is actually my personal research project. Yeah, if you're not familiar too much with MIMO, well, it basically means that massive MIMO means that you'll use a lot of antennas at the base station, something in the order of 50, 100, or even more, which allows you to do to spatially multiplex users, to form very sharp beams and spatially multiplex users. So we have, today OpenAirInterface supports arbitrary large antenna arrays in the so-called transmission mode 7. So that's not yet what I would call massive MIMO, but it at least allows you to support a large number of antennas and to do beamforming. And other transmission modes are in development. We also recently kicked off a project on 5G new radio. So you know 5G will introduce a new radio interface, which they call the new radio. And we've already started to look into this, and we're planning to develop this as well in OpenAirInterface. And another project that we're going to start very soon is Multifier. So this was mentioned before. So Multifier is very interesting. Multifier is a specification that builds on top of release 14 LTE with some additional features that allows you to use LTE entirely in an unlicensed band. So today, if you take release 13 or 14, there is this option that you can have additional LTE carriers in unlicensed band, but you always have to have the basic connectivity in a licensed band. And Multifier, so this is actually an activity outside of 3GPP. Multifier is an additional specification that allows you to use LTE in unlicensed band only. And so we're going to start, so this makes it more attractive for private networks, for small players. They don't have to bother about the license in this case, the spectrum license. So that could be a very attractive solution. So this development will be started in autumn, I think. So hopefully we'll have something in a year's time from now. But anyone who wishes to jump on the train is more than welcome to do so.